Okay, we are given this, we're asked to evaluate the integral. In this first one, the power of tan is even, while here is even, the power here is odd, while here is odd. So that two main things we have to know here, that two major formula we're going to use in solving the integral of any product, tan and tan sec. So what you have to do is that if you are given integral maybe tan mx sec nx dx, so the first thing you have to know that if m, that's the power of tan, is odd, you let u to be equal to sec. Do you get? If the power of tan is odd, you let u to be sec. And since if you differentiate sec, you have tan sec. So the next thing is to save a factor of tan x sec x because of this derivative. You save it, and finally you use the Pythagorean identity 1 plus tan squared x equal to sec squared x. Since we've let u to be sec, so we need to convert everything concerning tan to sec using this identity from here. So we have four key points here. M is odd, you let u to be sec, save a factor of tan and use Pythagorean identity. Or if n is even, that's power of sec is even, you let u to be tan. And since you've said u to be tan, if you differentiate tan, you have sec squared. You now save a factor of sec squared x, yes, because of the derivative, and now use the Pythagorean identity. So these are the four things in each of them. So let's solve the first one. We have integral of tan x raised to power 6 sec x raised to power 8. So what do you notice? Which category? The second one, because sec is an even number. So what do? You let what? U equal to tan x and save a factor. You save a factor of sec squared x. So what do? We continue. So this is tan x raised to power 6. Since I have to save a factor of this, so I'll write this as sec 6. So I've brought in this here. So the next thing is coming to here, because we'll let u to be tan. So everything we're going to solve in the equation will be in terms of tan except this. So if you make tan the subject of formula here, that's tan squared, you have sec squared minus 1. So what I will do, I will write this as sec squared x raised to power 3 sec squared x dx, so that so wherever I say sec squared x, I call it 1 plus tan squared x. So that's it. So it's now logical. If we now let u to be tan x, if you differentiate u, you have sec squared x dx. Okay, so we have integral of, this is now u raised to power 6 times 1 plus u squared raised to power 3 du. So this is the u's. So move to other page. So we expand this integral of u raised to power 6 times 1 plus 3u squared 1 plus u squared plus u raised to power 6. Okay, let's just close this. Du. So we have integral of u raised to power 6. Let's open up this. This is 1 plus 3u squared plus 3u raised to power 4 plus u raised to power 6 du. So this integral of u raised to power 6 plus 3u raised to power 8 plus 3u raised to power 10 plus u raised to power 12 du. So we now integrate, which is u raised to power 7 over 7 plus u raised to power 9 over 3 plus 3u raised to power 11 over 11 plus u raised to power 13 over 13 plus k. So we substitute. Our u is tan, so we have tan x raised to power 7 over 7 plus tan x raised to power 9 over 3 plus 3 tan 11, that's tan x raised to power 11 over 11 plus tan x raised to power 13 over 13 plus k. So that's our answer. So coming to the second one, we have integral of tan x raised to power 7 sec x raised to power 5 dn. So in this case, tan is odd. You remember the first one, look at this, the first one, sec is even. So look at first even power of sec or tan. So in this case, we are using tan because that is it odd. So what do? You let u to be sec and save a factor of tan sec from what I explained. So I can write this as integral of tan x raised to power 6 times tan x, which is this, and this is like sec x times sec x raised to power 4 dx, because I want to save a factor of tan sec. And remember, our u is sec, so we'll need to write this. So this is like tan x raised to power 2 or in 3 tan, or maybe let's write this. Let's write sec raised to power x raised to power 4 tan x sec x dx. So just I move this to this. Why this is this? So, and remember, our u is sec, so we need to convert this to sec. This is sec squared x minus 1 using Pythagorean identity. That identity I told you before in the first speech. This identity. So now from this, it's now easy for us that let u be sec. If you now differentiate sec, we have tan sec. Tan x dx. So we now have integral of u raised to power 2 minus 1 or raised to power 3. Why this is u raised to power 4 du. And if we expand this, this is u raised to power 6 minus 3u raised to power 2 or in u squared minus 1 minus 1. So times u raised to power 4 du. So we have integral of, okay, I'm opening up direct. I have u raised to power 10 minus 3 u raised to power 8 plus 3 u raised to power 6
minus u raised to the power 4 du. Just I opened up. Okay, I think that's what we have here. Okay, let's continue. So we integrate now. This is u raised to the power 11 over 11 minus u raised to the power 9 over 3 plus 3 u raised to the power 7 over 7 minus u raised to the power 5 over 5 plus k. And without that, u is sec, so we have sec x raised to let's raised to the power 11 over 11 minus sec x raised to the power 9 over 3 plus 3 sec x raised to the power 7 over 7 minus sec x raised to the power 5 over 5 plus k. So that's how you solve such problem. You check the powers of tan and sec. If it's for tan, if it's odd, you let u to be sec and save a factor of tan s and use the Pythagorean identity. So that's the general way of solving such problem. Thank you.